Hi everybody, this is Eduardo Suarez. Today we're going to do something a little more advanced. We're going to look at this iRVision 2D configuration where we have two robots. We're going to call robot 1 to the robot on the left and robot 2 to the robot on the right. And the interesting part of the configuration is that the camera is connected to robot 1 and robot 2 is the one that holds the calibration grid. The way that this configuration is going to work is that iRVision 2D option package is going to be installed only on robot 1, and also we're going to apply the offset data to robot 1. In this case, we don't need to have the iRVision 2D option package installed in robot 2 because its only job is to hold the calibration grid. To make the configuration work, iRVision needs to communicate between the two robot controllers, and to make this communication, RIP interface needs to be configured. RIP stands for ROS interface packet over Ethernet, and we're going to see in a moment how this configuration is done. ROS stands for Real-Time Operating System, and this is an interface protocol over Ethernet feature that allows the robots doing the common job to share information. There is one more thing that is required. Both robots need to have the same application user frame with the same number. That means that we cannot use the user frame number 0 because this is not a common user frame for both robots. As is shown in this illustration, we're going to need a user frame attached to a fixture in such a way that both robots share the same user frame. We're going to start with a work cell that I have already created. Here we have a configuration with two robots. The robot on the left will be the robot 1, and it's the one that holds the camera. We can see that I have the camera here, and also if we go to the robot controller 1, we're going to see the camera connected to the vision on robot 1. The robot on the right will be robot 2, and it's the one that holds the calibration grid. If you don't know how to configure two robot controllers on the same work cell, first you create a work cell with one robot controller, then you select robot controller, you just right click, select add robot and single robot serialize wizard. And then you just follow the normal procedure for adding a new robot. And when you finished, you will have a new robot controller added to the work cell on the cell browser. I'm going to show you now how to configure the interface communication between the two robot controllers using RIP. I'm going to show you first the way that you do in a real robot controller, and then the way that you do in RoboGuide. First, we're going to install the option packages. We're going to open the teach pendant. We're going to select robot controller 1. We're going to go to status. We're going to select type. We're going to select version ID. We're going to go to next and order FI. And you're going to see here that I have installed the iRVision 2D package. I have the Ethernet IP scanner, and also I have the ROS Ethernet packets. Now we're going to select robot controller 2. And we're going to do exactly the same. We're going to select status, type, version ID. We're going to go to order F5. And you're going to see in this case that I don't have the iRVision 2D package, and I only have the Ethernet IP scanner and the ROS interface packets. Robot 1 is going to be the robot master, and robot 2 is going to be the slave. So for the robot slave, I believe we don't need to have the Ethernet IP scanner, only the Ethernet IP adapter will be enough. That's something you will have to double check. But in this case, I selected the Ethernet IP scanner, just in case we have a communication with the PLC. Now that we have the option package installed, we're going to select again robot controller 1. We're going to select menu, setup, Next, host communication, and we're going to select TCP/IP on the setup protocols. We're going to go to details, and you can see here that we have a name. We can rename it and call it Robot1. And we're going to set the IP address. It's going to be 127.0.0.2. And we have the subnet mask. Just remember, if you change the IP address, you need to cycle power the robot controller. Also, we're going to select now the robot controller number 2. We're going to select menu, setup, host communication, TCP/IP, and we're going to give it a name. We're going to call it Robot2. We're going to set the IP address and the subnet mask. And again, you want to cycle power. One thing that you need to consider that the IP address can be on any range. The only thing that you need to keep in mind is that the robot controller 1 is going to be the master in our case, and the robot controller 2 is going to be the slave. So the one that is the master has the lowest IP address, and both they have to be consecutive IP address. So we have selected .2 and .3. One more thing is that in this case, I'm considering the port number 1. Here you can select between the port number 1 and the port number 2, just clicking the port option. And normally when you have in a real situation, you have, for example, port 1, that's going to be the one that's going to be connected to the plat network or probably to the PLC. And when you set up the cross communication, you want to have a port just dedicated to the communication between the two robots. So in a real situation, probably use the port number 2. With this, we have the TCP/IP communication configured. Now we're going to configure the write communication. We're going to select preview. We're going to select write, and we're going to select detail. The write communication has to be configured first on the slave and then on the master. Robot controller 2 is our slave, and if you look at the setup write on the ROS Ethernet packets, it has to show slave. In the case that it shows master, there is a toggle button in here that you can select between slave and master. So now we're going to have the robot name, we're going to have the port Ethernet, we're going to have the IP address, and we're going to change this one for the master. In our case, it's going to be 2, and the slave is going to be .3. The member index, 1 is going to be the master, and 2 is going to be the slave. And you're going to notice here that this list is uninitialized. So the next thing that you need to do, you need to select auto, and I can show you here how this is going to look like on RoboGuide. So for that, I'm going to show you on a screenshot. So this screenshot shows the configuration for the slave. You're going to select auto. Then on the next screen, it's going to show repower after receiving the data. You're going to select yes. And then it's going to say waiting for data, preview to cancel. At this point, the write communication is already set on the slave, and we need to go back to the master and do the communication over there. We're going to go back to the work cell. We're going to select robot controller 1. We're going to select write, and we're going to go to details. In this case, it needs to show ROS Ethernet packet master, and if it shows slave, you just toggle with this button over here. It's going to show the name. It's going to show the port for the Ethernet. It's going to show the IP address, and the number of members is going to be 2. And again, the list is going to be uninitialized. At this point, what you need to do, you're going to press auto again, and I'm going to show you in a screenshot how this is going to look like. So this is the configuration for the master. You're going to select auto, and the next screen is going to show put all the slaves in auto mode. We have already the robot controller 2 in auto mode, and you're going to select continue. And at this point, it's going to set cycle power for setting to take effect, and it's going to show the list with the host name and the internet IP address. And with this, we have the communication set up for the RIP on the master and on the slave. So this is the way that you would do in the real robot controller. I'm going to show you now how you do that on RoboGuide. We're going to go back to the work cell. We're going to select cell, RIP setup, and here you're going to see the Robot 1 and Robot 2 with the IP address. We're going to select on the column for the robot controllers, and we're going to select Robot Controller 1 and Robot Controller 2, and we're going to apply the changes. And we're going to press OK. Now it's going to say that you want to update all RIP controllers with this ROS IP configuration. We're going to select yes, and the work cell is going to restart. We can look at the RIP configuration now. If we go to menu, setup, host communication, wrap, and we go to details, you're going to see here for the master, it shows the list for Robot 1 and Robot 2, and similarly, it's going to be the same for Robot Controller 2. As you can see here. And with this, we have already the RIP communication setup in RoboGuide. Now we're going to set up the user tool and user frame for Robot 1 and Robot 2. We're going to select Robot Controller number 1, and we're going to select the user tool number 1. This is the one we're going to use for the Robo Gripper. We're going to open the Teach pendant, and we're going to select Robot Controller 1, and we're going to change the coordinates to tool. And we want to set up the user tool in such a way that is as is showing here. That's the same orientation that we have for the calibration grid. Select the robot controller number 2. On robot number 2, we're going to have a user tool number 1 that is not going to be relevant for now. And we're going to have a user tool number 2 that is going to be our calibration grid frame. We're going to see in a moment how this is done. And the next thing we need to do, we need to configure the user frame for Robot 1 and Robot 2. And as I mentioned in the introduction, this user frame has to be common for both robots, and it has to be the same user frame number. So if we select Robot Controller 1, we're going to go to user frame 1. That's going to be the application frame. And you can see that I selected this corner on the table with its orientation. And now if we go to Robot Controller number 2, and we select the user frame number 1 again, it's going to be our application user frame on the Robot Controller 2, and it also has the same orientation on the same point. So this application frame is a common user frame for both Robot 1 and Robot 2. Now we're going to configure the calibration grid frame for Robot 2. Since Robot 2 doesn't have iRVision, we can use automatic calibration grid frame setting. Instead, we need to use the 4-point method. In this case, I cheated. I used the direct entry method. Since I know the position of the calibration grid relative to the flange of the airline tooling, I move the calibration grid frame to that point. We're going to open the teach pendant. We're going to change the coordinates to tool. And as you can see here, the calibration grid frame origin is on the origin of the calibration grid with the right orientation. We can also open the teach pendant, go to menu, set up frames, and in tool frames, tool frame number 1 is not used, and tool frame number 2, it has these settings. Now we are ready to start with our vision configuration. We're going to select Robot Controller 1. We're going to select Robot Internet Explorer. We're going to go to iRVision and Vision Setup. First thing we're going to do, we're going to create a new vision data. We're going to give it a name. And we're going to go to Edit. We're going to select Advanced Mode. And we are in the camera setup. Over here, we're going to select our camera. It's showing already the grid. For robot mounted camera, we're going to select No. And for calibration, we're going to select grid pattern calibration. We're going to go to calibration setup. And robot to be offset is going to be this robot on group 1, application frame. We're going to select the user frame number 1. Grid spacing is going to be 30 millimeters. Robot health calibration grid. We're going to select yes. And you're going to notice now that we have the robot holding grid. Instead of selecting this robot, we're going to select robot number 2. And it's going to be on group number 1. So this is going to be the main difference. Now that we have the ROS communication setup, we are able to see in iRVision the robot number 2. For setting calibration grid position method, we're going to use frame. We're going to go to calibration grid location, and the calibration grid frame is going to be a user tool, and we're going to select user tool number 2. And iRVision is going to know that we are using the user tool number 2 from robot number 2. We're going to skip the calibration position status because this is not used when you are holding the grid with a robot. And we're going to go to calibration. Of number of planes, we're going to select 2 planes. And we're going to take a snap. And we're going to set the position for the first plane. We're going to select Fine. We're going to adjust the control points. And we're going to press OK. Now we need to move the robot to the second position. And for that, we're going to go back to the work cell. On the work cell, we're going to select robot controller number 2. We're going to open the teach pendant. And we're going to select data, position registers. We are right now in position register number 2. And I'm going to set the coordinates to user tool number 2. And user frame is going to be number 0. And now we're going to select the position register number 3. That's going to be the same position with an adjustment of 100 millimeters on the Z height. And we're going to move to that position. Now we're going to go back to iRVision. We're going to take another snap, and we're going to set the position for the plane number 2. We're going to select Fine. We're going to adjust the control points. We're going to press OK. And we have our second position. Now we just can check the calibration points and the calibration result. You can notice now that the position of the calibration grid relative to the application user frame is 360 on the X, 290 on the Y, and 777.5 on the Z. And we can compare this number to make sure that this is correct. We're going to go back to the work cell. We're going to change the row position to position register number 2. We're going to select the measurement tool, and you can see that we have 777.5, 290, and 360. So that result that we got was correct. Now we're going to move robot 2 out of the way. We're going to put a part on the gripper for robot 1, and we're going to move the robot 1 to the vision position. We're going to open the teach pendant. We're going to go to robot controller 1, and here I have already a program created. So we're going to run in step mode. Now we are in the vision position, and we're going to go back to the iRVision. We're going to create a vision process. We're going to select to the single view vision process, and we're going to give it a name. I go to edit. On the parent tool for the vision process, we're going to select the camera. It's going to be camera 1. Number to find is going to be 1. Offset mode is going to be tool offset. Robot holding the part is going to be this robot in group 1. Offset frame is going to be user tool, and we're going to select user tool number 1. And image log, we are not going to log any image. We're going to select snap tool. We are not going to make any changes over here. We're going to select the GPM locator tool, and we're going to train the part. And now for the degree of freedom, we can select something like -10 to +10 degrees. We're going to do an snap and find, and we're going to go to offset data calculation tool. The Z height is going to be 0, because I put the part in the same position as we had before for the calibration grid, and we're going to set the reference position status, and we're going to save it. So with this, we have the reference part, and we're going to run the vision process on the TP program. We're going to go back to the work cell. We're going to continue running the program. We run the vision process. We get the offset data. In this case, the offset data is 0 because this is a reference position. And we're going to place a part on the table. We place the part on the table with the edge of the part on the edge of the table. And we're going to go back to the home position. Now what we're going to do, we're going to move the part. We're going to move it for now on one direction without any rotation. We're going to run the program again. We're going to run the vision process. We got our new offset data. And we're going to place a part. And we are able to place a part with the correct offset data. Finally, we're going to give it a rotation. We're going to rotate 7 degrees. And we're going to run the program again. We got again the correct offset data. And we're able to place a part with the correct offset. So one thing I want to show you here is that when you set the instruction for the vision get offset, we're going to do that again. We're going to select the vision get offset. You're going to see here that there is a new option that is the robot. And in here you can select the robot that you want to get the offset from. You can select this robot or you can select robot number 2. In this case, we don't need to do that because we are applying the offset to the same robot. So we just simply select choice and we select the vision process and then we select the vision register number. In conclusion, if you want to communicate 2 or more robots on iRVision, you will need to set up the driving interface. One of the robots will be the master and the other ones will be the slaves. For this particular configuration, when you have the camera connected to one robot, and this is a robot that's going to be offset, and another robot is holding the calibration grid, you will need to set up a common application user frame. I show you here that configuring iRVision is very simple, and one of the questions that you may be asking is when you need to use this kind of configuration. This would be a camera calibration design option where you have multiple robots. You might have an application where you have rich issues, or you might be holding a big part, or simply you might have 2 or more robots performing a common task, such as coordinating motion. I just want to make you aware that this kind of iRVision configuration exists. I'm going to leave the link to the work salon description below, and thank you for watching.